OK, the last topic of today and of the web security unit in general is to talk about CAPTCHAs. You've probably seen these before, but we'll quickly cover what they are and how to think about them. So first, why do CAPTCHAs exist? They exist because websites are supposed to be for humans. So for example, a login page is meant for a human to type in their password. The login page is not meant for an attacker to do an online brute force attack where they write a script to try every single password. That is not the intended use of the login page. So sometimes there are websites where we don't want robots to access them, and we only want humans to access them. Another example where robots shouldn't be accessing websites might be denial of service, where a robot is flooding a server with requests in the attempt to overwhelm the server and take it down. And that's something we'll see again later as well. Or maybe like an email server. That's something that should only be used to send legitimate emails and not spam emails. So we don't want robots automatically sending spam emails. We don't want robots on our ticket websites to buy tickets and resell them ahead of time before humans can buy them. So those are all examples of cases where robots using websites was not the intent. So to solve that, we've introduced something called the CAPTCHA. And this is a challenge that's easy for humans, but harder for computers to solve. And the goal is to try and figure out if this is a human making the request or a robot making the request. So the way you use it, you present a CAPTCHA to the user. If it passes, then we think they're a human. If it fails, they're a robot, and they're not allowed to access the website. Now, a CAPTCHA stands for this funny little phrase, but we will not ask you to memorize that. So examples of classical CAPTCHAs, and nowadays there's all these weird ones that we've seen pop up in response to LLMs and things like that. But kind of some old school CAPTCHAs you might have seen before, giving you distorted text that's hard for computers to read. Identifying images used to be a hard problem for computers. So this was something that only humans were good at, like picking out the lion or the dog. Or maybe listening to an audio clip and typing out what the words were. This also used to be a problem that was hard for computers. So it allowed us to figure out if this was a human or a computer. Nowadays, a lot of this is less true. So there's actually a secondary purpose of CAPTCHAs in today's world of machine learning and large language models. So if you've ever taken some sort of AI or machine learning class, you might know that modern systems require a lot of training data in order to train their systems. So how does ChatGPT know how to answer your question? It trained on a lot of previous training data. Or how does a self-driving car know what a traffic light looks like? It's been trained on a lot of manually labeled data. So where does the manually labeled data come from? Well, when Google asks you to pick out the motorcycle, maybe it's using your human answer as training data to feed into its systems so that its computers now know that this is an example of a motorcycle or a stop sign. So kind of a side point, but if you've ever wondered why modern AI works or where the training data comes from, one possible source might be asking users for CAPTCHAs. So some modern issues with CAPTCHAs, especially now that we're in the ChatGPT age, one problem is that computers have gotten a lot smarter. Now they're good at detecting audio and automatically saying what the audio corresponds to. They're also pretty good at recognizing images and even recognizing distorted images. So because computers have gotten smarter, CAPTCHAs have to get harder so that we can distinguish humans and computers. And one problem that I think people are still wrestling with right now is the problem that CAPTCHAs are now so hard that even humans are having trouble solving them. So because we had to make them harder to defeat computers, we've actually started to defeat some humans as well because computers have gotten so smart. And this produces accessibility problems where maybe not all humans can solve the CAPTCHA. Like if you ask me what these words say, I have no idea. And so by defeating the computer, we might have also defeated the human. And that's kind of an open question for how you make modern CAPTCHAs to distinguish between smarter computers and humans. And another problem is that not all bots are necessarily bad. So CAPTCHAs are good at distinguishing humans and robots, or at least they used to be, but they're not necessarily good at distinguishing which bots are good and which bots are bad. So a bot that's sending spam is bad, but one example of a bot that might be good is a crawler bot like the Internet Archive, which downloads web pages automatically to save them for the future. That could be an example of a good bot, and CAPTCHAs would stop the good bot in the exact same way that it would stop the bad one. So those are some modern issues with CAPTCHAs, and the more we move on in time, the less relevant this slide gets. So maybe in the future there will be different types of CAPTCHAs, but who knows? So modern attacks on CAPTCHAs. Well, one possible attack, if you want to execute scripts as a robot, but there's a CAPTCHA in place, is to just pay humans to solve it for you. So even if the robot is unable to solve the CAPTCHA, you could just pay a bunch of humans to help you solve the CAPTCHAs, and now you're back to automating something like a spam bot or some other malicious bot. So CAPTCHAs can still be defeated, and in fact, there are modern services that let you pay a couple of cents per CAPTCHA, and they're automatically solved for you. So this is kind of a security as economics problem. Even though CAPTCHAs stop robots, they don't stop robots that have a lot of money and can pay humans to solve the CAPTCHAs for them. So even if you just Google CAPTCHA solving service, it seems like there's all these shady websites that try and solve CAPTCHAs for you for a small fee. So that's it for CAPTCHAs. To summarize SQL injection, the main problem was that untrusted input was passed into the SQL query and then parsed, and this allowed the attacker to construct queries that they could run on a SQL server. And we also talked about how databases are used for web servers to store data. We talked about blind SQL injection, where the feedback isn't quite obvious. That makes the attacker's life a little bit harder, but not impossible. And we talked about input sanitization and prepared statements as defenses. And in particular, prepared statements where you pre-compile the query are basically impossible for attackers to circumvent. And we talked about, in general, command injection, where untrusted input is passed into some language and then parsed as that language. And this is something that can happen in other languages as well, like Bash in your terminal. And to fix that, we should be using safe API calls, and we have to consider human factors, where humans don't always look up the right documentation. And then we talked about CAPTCHAs, which are easy for humans, but hard for robots. But nowadays, with the continued development of LLMs and stronger AI models, the differences are getting more subtle, and it's not entirely clear if we're able to distinguish between humans and bots as effectively. But even then, there is still the attack where attackers can spend some money to get around CAPTCHAs and allow their malicious bots to do malicious things. So that's a quick summary of CAPTCHAs and SQL injection. And with that, we are all done with the web unit. And networking is the next unit.